Hey everybody, Jeff here. Welcome back to the channel. Today we're continuing our series of videos on that Miami condo collapse in the beautiful town of Surfside, Florida. And in today's video, folks, we are studying the pool deck because we want to find out how in the world can a collapsing pool deck drag down an entire building. So we're going to be looking at everybody who's ever touched this pool deck and put their hands on it. We're going to look through permits and drawings and repairs that have been made over the years. And we want to answer the question, could it have been the architect's drawings were wrong? Could it have been the implementation of the building? Did the contractor that originally built the building screw up? Did somebody come along later on and do some work on there and screw up? The result of exploratory work done on the pool deck last year. So we're going to look at all of these and some new video evidence that's come in. And let's get started. Okay, now we want to start off by looking at some overhead shots of the pool because this is going to give us a lot of great information. We got a lot of these pictures from the MLS listings. In fact, I want to thank Jen Patton. She actually sent me this one here, which I think is our most valuable picture. So if we zoom in and look, and we think this was done in 2019. It says November 2019, but sometimes the real estate agents, they will reuse photos because the palm trees are gone, and we know they were taken out probably sometime between 2017 and 2018. But look at all of these stains all over here. This means you had standing pooling water here for quite some time in the past. And pay attention to this area right here. See all of that staining over there too? Even though this area of the pool deck did not collapse, but this, you'll see in a number of pictures, always shows water standing there. This is the part that collapsed. It started here and goes over here. Barely misses the pool. The pool stayed intact. The pool never even leaked or anything. And then the line runs all the way over here to the building and then comes back here. And then down to where the covered parking is just behind this canopy. That part, a little bit of that collapsed also. Now these guys from the Dolo Experience had the best 4K drone video on YouTube. I'll put a link to it down below for you. This is the main part that dropped with what we call a punching shear, leaving all of those columns that were in this area pretty much intact. If you remember from the last video, folks, we think that this spot right here is where the column is that came down, the one that ripped. And let's figure out where we are. These are the 5 columns that collapsed. Here's 1, 2, 3, 4, 5. And as we always do, we reference them off of that shear wall right there. So there's our 5 columns, right? And so if we're saying that this is the column outside the building that fell, remember 1 column south of the building, this is it. And when you look at the engineer's drawing from 2020, from last year, that puts that column right smack dab in the middle of this planter here. And look at this, coincidentally, right next to this site where they did that excavation. We don't know when they did the excavation, but it was obviously before the October meeting of the HOA. So this one right here is the one right up against the wall. There's a column in here, and we'll show you in a second. It'll be much clearer. There is a column right here in the wall, and then this wall right here leads south from the column right to the next column here, which I think is right almost in this corner here. Now, if you look at here on page 11 of the engineer Morabito's drawings, these are the drawings that they made in April of this year to detail some of the repairs they were planning to do. But here's probably the best drawing yet that shows exactly how everything is related. See, so again, here's the ramp. The ramp ends here. There's 14, there's 27, and then here's 27/28. And you can see it lands right in the middle of the planter. And the other one, next to space number 76, he also lands here in the middle of a planter. All right, so let's zoom in and take a little bit closer look at it so we can see. Okay, so here we are looking at it enlarged, and this is our area. And remember, these are the big square planters that were not in the architect's drawings that were added later, and we don't know if they put drains in them. Here's our column. There's the site where they did the excavation and the exploratory work. There's the picture of it, right? So this site was just immediately to the left of this planter. So let's superimpose this over the parking garage so we can get a better idea for where we're at. Okay, so I'm going to overlay the upper deck on top of the garage here and show you something. Before I do, let's just take a look right here of where we're at. Remember, we're by that shear wall right here, and we count over 1, 2, 3, 4, 5. Those are the 5 columns that in total we think collapsed, although probably the first 2 or 3 here in the middle are the ones that gave way first, right? Look where we are here, space 27, 26, 28, and 29. We know this post survived, as we show with the green arrows. See, because right here is 28, right here is 42. This one is 76. This is the main drive through the garage, is right through these two posts. So the post we're looking for between 27, 28, it'd be probably somewhere right around here under this rubble. Base number 28, this post survived. It's still sticking up out of the rubble. Nothing happened to this guy because you had a punching shear right here when the pool deck collapsed. But we think that when the pool deck collapsed, it actually either disabled this particular one, the one between 27, 28, that we think it fell over, as we showed you in the tourist video, with the column felled over onto the floor. Okay, so here we can see as we move this over, note where the stairs are. And the stairs here. I'm going to line the stairs up with the stairs, see? So everything is now lined up there. And if you notice there, see, our columns come in and line up perfectly with these. Now I don't have the fifth one on there. And then my two down here line up perfectly inside the red circle. So here's the outline of the building, the southern wall of the building. This is our column that we think broke, actually part of that planter from last year. Here's the little excavation work they did. So this excavation work that they did was right here. Let me move this out of the way and show you where it was. It was pretty much right here in this area, and this is the drive. Okay, there's no parking spaces here. That you come off the ramp and you're driving into the garage. So that excavation work was done right pretty much over this red arrow. Coincidentally, near where they have a shield on the ceiling there to reroute the water, and where a lot of the most amount of paint peeling, stalactites, and the beam over here is in bad shape. This beam looked like it was bowed on the bottom, and it had all sorts of paint peeling off of it. This beam was not right. I think it's waterlogged myself. Okay, so here's the other view that I wanted to show you. That this is one that always makes me suspicious when I see it. And we showed you this, I think, a couple of weeks ago in our other video. I think this photo was done here. It looks like it's saying down here, September 2020. Look at all the water that's pooling right here. Okay, perfectly clear skies. There's no rain anywhere, but I see wet spots all along here. And that was that spot that I showed you in the previous photo. Why do I always see pooling of water here and over here? But I'm really focused on this Bob's barricade right here, because this has me really worried. So let's zoom in on it and take a look. Now, we talked about this in the last video, just briefly. I touched on it. This right here is a 3 foot by 3 foot cutout section where last year in 2020, the engineer told the construction company that they were getting ready to start on their 40-year recertification and repairs, told them to make this 3 foot by 3 foot cut, and they're supposed to patch it right up, but apparently they didn't. Now, also when looking, well, how can the deck falling, pull down the whole building? I want to zoom in here and take a look. Remember, this is our shear wall here, and this is the end of our building. It's right here. This is the southern end of the building. Here is our column over space 27. You notice how this one's a 16 by 16, and I believe they're 24 by 24 on the other part of the building that survived. But look at this one. This one's a 12 by 16. So if something is going to happen over here, you can bet that it's going to possibly pull down, and this would be the weakest member right here that would possibly shear through or crumble. And once this starts buckling and things start dropping here, it doesn't take long for the domino effect to begin happening. We know this post survived, post number 28, because we've seen it in numerous. So isn't it strange how this one's a 12 by 16 going this way? Okay, with the skinny side facing north-south, but this is a 16 by 16. So if the deck drops right here and starts to pull things down, this one is likely to break. Remember, he's outside the building. This is the one that's in the middle of that planter. See, there it is right there. So if you look here at the legend at the bottom, you can see that the building that survived over here enjoyed these nice big old 24 by 24 inch columns, see, right here. And the part that collapsed only had the 16 by 16s and the 16 by 12s. Here's our magical spot here. Let's go zoom in and take a closer look and see what's happening. Okay, so remember here on space 27, this is the southern edge of the building. And I wanted to point out this note that they put on here. It says the bottom of the slab under the building shall be sprayed with half-inch urethane insulation. Now, I don't know how much waterproofing that's going to give for the slab underneath, but of course water could still get in anyway. Anyway, looking back at these two columns, so this one's 16 by 16, this is 12 by 16, with the flat side of it facing this way. So the pool deck is over here, and it's collapsing and coming down, mostly sort of straight down. So people are wondering, well, how could that have pulled out a column? But sometimes if you get something that wants to break halfway down, then there'll be a pulling motion this way. And so if you have something that's pulling this way, this column, I would think, would want to shear because it's only 12 inches at this point. It had the unfortunate positioning of being 12 inches this way. I question if this column was turned 90 degrees, would it still be standing in the whole building? It's still standing today. So I don't know why they didn't put any 24 by 24s on this section up here. And, you know, remember, this is only just supporting a deck at this point, so who knows? They've probably done all their calculations, and these are probably okay. Now let's look at how the water drainage and possible concrete degradation could have contributed to this, because you're going to find a myriad of answers here. It's not just one possible root cause. I think we're going to see several. There's not an engineer in the world today that would have walked in that garage and said, yep, this building's coming down. Yeah, we saw a lot of shocking things and a lot of leaks, but nothing, not one of those as a smoking gun that would say, yeah, this building's coming down any day now. It's the latent failures that you don't see are the ones that cause the damage, folks. It's the plumbing pipes that burst inside your walls, and all of a sudden 2 weeks later you're wondering why you have mold and $30,000 in damage. The latent failures are the really nasty ones, the ones you don't see. All right, so let's analyze here what could have brought the pool deck down and what's going on and how it's supposed to work. So here's your pool, and a lot of people don't realize, but the pool is at ground level here at grade, and it goes down and it rests on the floor of the garage. And your cement slab, which is about 9.5 inches on this pool deck, is supposed to be sloped on the top like any deck leading to a drain would be, and it is a 1/4 inch per foot slope. That's all required by building codes. Everybody has to do this, so that way when you have rainwater coming down on it, it runs down here at an angle to the drain where it goes off to the pipes and into the storm system. Here is our column here, M10, the one that we think failed first, and it's connected with a beam to the space 27 column right here, which is at the edge of the southern part of the building. So that's why we think the collapse happened here, that if this drops down with a shear, okay, somehow this broke. Now, some people think it's this planter that was on top of it, but, you know, the planters that were already there by the architect had drains in it. We don't know if this had a drain in it. I doubt there's enough water in here to cause a problem unless you had already unbelievably weakened concrete here. And then it would be, you know, multiple combinations of things. This applies, it's just as simple as when we do our tiling in the showers and we do our drain system. It's the exact same thing. So here's one that I did in one of my flip condos. So I'm using here a drain. This is a preformed deck right here, and it's slanted in all the way around towards the center of the drain. You see that? We start to add our Schluter-Kurdi membrane where I'm cementing it down with the mortar, and I raised here. The same thing as, say this is the pool deck. What happens at the edges? You see, water's going to get in. So what we do is we have to then add more waterproofing at the end that comes up. It rises up and comes up a few inches off of the floor there. So now you're creating basically a little bathtub to contain any water that lands on there so it can't pool anywhere and it goes down the drain. Here's when we finally add the floor tiles. And remember, with the curb, we went up and over the curb and extended it out this way and then put the cork on top of that. So this whole thing is self-contained. There's water is not going to leak out anywhere. You know that I've always told people, folks, if you don't tell water where to go, it will make up its own mind. So here I am directing the water exactly how to go. It's going to hit the tile wall, drop down, come down the tiles, and then go to the drain once we have that cut out. And there it is there, see? But you can see it's all slanted in towards the drain wherever you look. And then, of course, there is the final product that I created. And then, you know, as beautiful as this looks, folks, you don't know what's behind it. And like I've said, it's always the latent problems that you don't see. What if I didn't waterproof this correctly? This is going to eventually leak, you see? And it just seems like they spent more time and effort on the lobby of this condominium building, as you can see here. They spent more time and effort on the lobby of the building and made that look nice and pretty than they did down here in the garage, where if you don't take care of these issues, you're going to have latent cracks and failures and drippings, and you're ignoring the stalactites that you see all over the place. Okay, another thing I wanted to focus on too that sort of has me concerned is right here when you look at the beam area. See, when you look at where this beam is, I question why they really needed to connect these two together. And in fact, had they just put an isolation seam right here between the slab and the condo building, I'm pretty confident this whole thing would have just done a simple punching shear and dropped straight down without pulling down the building with it, because I think this beam is sort of key to the equation that once this column collapses, this beam, there's nothing holding it up, and it is then free to drop down and possibly tear into this beam, making this beam collapse now. All right, so I want to show you here. This is what a textbook punching shear looks like. The whole slab just drops when the weight just suddenly becomes too much for the reinforcement connection here to support. And they sometimes drop like this, straight down. Sometimes they may drop at an angle where maybe one part wants to do this. Okay. Now the problem with this is if this guy wants to drop down at an angle, what do you think is happening? Now suddenly we have forces pulling in this direction on this particular column, which is going to make this particular column now want to kind of go like that too. You see that? So you see what's happening here now? So when that column wants to start to move and everything's dropping down to the ground like this, it's like playing musical chairs. You're left without a place to sit there, folks, on that beam. And next thing you know, that beam's going to want to pull. And when he wants to, let me try to rotate him down a bit. When he wants to pull down a bit and start to peel away and drop off, I don't know how well he's rooted into the slab there, but you can see what's going on. And now everything's kind of collapsing at once here, including the planter. So is the planter the cause? You know, a lot of people keep putting that out there. I don't think it is. I think the planter was just there when the real cause happened. I think that years and years of this waterlogged concrete deck here, it just got so weak, and with all of the cracks that we didn't see, it just fell apart all of a sudden at once. Okay, so now looking at everything here where I've added some more dimensional labels and stuff, you can see all of the columns underneath the building are 16 by 16. And here's L10, this is the one that's at space number 27. And then M10 is the one at space number 28, 27. So right in the between the two spaces. So 28 would be over here, 27 would be over here. And there's the typical beam A. Okay, but look at this. So here's the Achilles tendon of this column M10, is the fact that it's rotated and oriented such that the 12-inch dimensional side is against the shearing force. So you really only have a 12-inch column here, even though it's a 12 by 16. In terms of the shearing forces and the pulling shear direction that you see here, you basically only have a 12-inch column. And then while we're on the topic of that, I think this is somewhat misleading. I don't know. I want you to take a look at this. Tell me whether you think this is an optical illusion or not. So we're going to look here at the top of this column, L10, in the photograph. Okay, so here's another screenshot that I took off of that garage video. I want to zoom in over to here, because look over here. Here's the beam, right? Here's that column. And what's happening up at the top of the column here? Why do we have all of this rippling? That doesn't make sense to me. It almost looks like it's been under too much compression. And is this staining? Is this thing waterlogged? I mean, there's a lot of questions we have here. But why does this look like this? Why doesn't this look like a straight, perfect column like all of the other ones do, with perfectly sharp, straight edges? Why do you have all of that? See, that's why I keep saying every time we look at more pictures and more frames, it just invites more and more unanswered questions. Something just doesn't look right there. So if that's true, and if it's buckling in a couple of inches on this side and a couple of inches on this side, this means that this column is no longer a 16-inch column. That now makes it a 12-inch column. See, so coming back here, this is the one we're talking about. All of a sudden, there's all of those little waves on the top of the column there that just don't make any sense. Okay, now I've said it on my other videos, and I'll say it on this one too. Why was this beam done differently than the others? It's in the original plan, so it's not an afterthought. But why does it connect to the side in a shearing manner rather than on top of the columns? Like you can see, all of the other beams in here are connected on top of the columns, so that the load gets carried straight down to the column instead of any potential shearing. Okay, now I wanted to zoom in over here because a lot of people have asked me about this pipe here, and this looks like a lot of repairs have been done. This is a typical sort of we call them either mission connectors or Fernco connectors. They're perfectly normal, and you can see the big band they have on there, the hose clamp. I don't really see one on this side, so I'm questioning if there is one or if it's black or what the deal is, but it's okay. They're somewhat reliable if they're clamped. Although I would not have implemented it this way, I would have just done it with the parts. I don't know why you would have one of these elbow type connectors part instead of just using the real PVC part and cementing them in. So that kind of doesn't make sense. But again, I don't see anything wrong with that. That's not a smoking gun that I can see. Yeah, so this is what we would probably call a handyman fix. I don't think any legitimate licensed plumber would do it this way. But I also don't think that brought the building down. And once again, folks, God bless these real estate sites that keep providing us these valuable pictures here, because let's start zooming in on this one. This one we're pretty sure was taken late last year because they've added the yellow stripes. Remember we talked about these? But look what happens as we zoom in. This is probably the single best overhead shot we've come across yet. I'm going to zoom all the way in and look what's happening. Remember, this is our magic spot we were talking about. Our column M10 is right in here. And look what is right next to it. Still exposed is that 3 foot by 3 foot extraction that they did. And I believe right here is where they took that core sample that goes all the way through the concrete slab and down into the garage. I don't know. That doesn't look like it's been patched up to me, folks. So let's take a look real close at what those engineers' command was to the contractor when they told them to cut this 3 by 3 hole here. Okay, so here's that page that they submitted to the Homeowners Association in October of last year. And it looks like this drawing was prepared in July of 2020. You can see it right here. So I'm assuming that's around the time that all of this action was done. So let's zoom in and take a look at those notes there. Notes 5 and 8. Okay, so read along with me if you would here, folks. It says right here, the contractor shall complete careful exploratory demolition of the paver system at the pool deck, document it, an approximate 3 by 3 area shall be demolished. The paver system shall be demolished down to the top of the existing waterproofing if waterproofing is placed directly on top of the structural slab. The contractor shall take proper precautions to avoid damaging the existing slab. Now over here at the end of it where he's telling them to do all of these tests and blah blah blah, demolish it down to the bottom there, right? But it says here at the bottom, reinstall the paver system at the pool deck. Replace/repair the stamped concrete at the parking area and restore the planter to the original condition. So my question is, it says note 5 and 8 right here. So my other question to you is, when you look at this picture, does this look like last July that the contractor put everything back? Don't know. It doesn't look like it to me. Does that mean anything's wrong? No. This could be pure speculation here. But like I said, sometimes failure modes have many potential causes. So water getting in through here, maybe it's unprotected here at this point. Water getting into these planters, although these we know have drains. We don't know if this has drains or this or this. We don't know if that makes enough weight to crash through, but it might if you have a weakened concrete deck that's been weakened from years of cracks and faulty repairs. Okay, so now let's look at the palm trees. Oh, palm trees? What? Oh, you didn't know? Oh yeah, they had palm trees there. They took them out. Let's take a look. Yes, sir, folks. You want palm trees? We got palm trees. Look at that. What have we here? They used to have palm trees in all of these planters on the deck, and you can imagine some of these taller ones add up quite a bit. Now, I believe these are sable palms, and if they are, they weigh about 100 or 150 pounds per foot. So this one's probably 20. These are probably 17, 18 feet here. Who knows? Taken by Google's car when they drove next door when there used to be a road there. It is March 2015 is when this was taken here. And we saw that it was there in 2014 as well. So they were probably added in that 1996 redecking that was done. Because I buy properties a lot, I spend a lot of time on the sat photos of the different property appraiser's office. So here's the Dade County one, and here's the view of the property, and you can see the year 2017 they still had those palm trees up. Okay, so here's our answer, because here is the aerial photo for 2018 from the property appraiser, and the palm trees are gone. I don't know why they were taken out, what their reasoning was, or how they took them out. And then you could see next door the construction is going on that 87 Park condominium. This is the one that the residents here in the building were complaining that during the building was getting a lot of pounding from next door here, and some people are saying, well, maybe that brought the buildings down. So we have no evidence of that. This kind of thing happens all the time in Miami. Never had a problem. Okay, now here's a 2019 shot, and you can see once again the palm trees are gone. And then of course here's the 2020, and again palm trees gone. I don't know why they took out all of those palm trees, but it must have been a big undertaking, and they must have used a crane of some type. So where did that crane park, or did they use heavy forklifts that maybe should not have driven on here? So that's another thing to think about. I want to know how they extracted those trees. More questions, folks. Every picture we look at, more questions. All right, so here's another thing I wanted to show you here. This is a video from the Wolfson Archives. I can't play it because they would charge $600 for this. So I'm just showing you the screenshot here from YouTube where it's on here. But many news stations never even reported this, but there was a crane collapse during the construction of the Champlain Towers that took place on June 9th, 1980. So you can go to YouTube and check out their video there for that, and you can see, again, this just keeps adding more and more questions. Did it cause any issues? You know, where did this crash happen? Did it cause any problems for the foundation? To get some clarity, folks, we go here to the original 2018 now famous engineering report from Morabito that told the Condo board what they needed to do. All right, so in that report here, he shows a couple of photographs that were taken of the garage ceiling. And look at this, folks. This right here, I'm pretty sure, is the pipes from one of those drains in the deck, possibly one from inside one of the planters. But even so, even though we have drains there, look, it was all cracked all the way around at that telltale stress crack that stretches out in like 4 different directions. And look at the huge stalactites there. They still had problems even around the drains. And then he points out here this really bad injection job here where they did some epoxy injections, but it was done by somebody who didn't know what they were doing, and in many cases they left the injection ports still hanging out. So read along here. They recommend that the entrance pool deck concrete slabs that are showing distress be removed and replaced in their entirety. That's how bad he thought it looked. Unfortunately, they are under brick pavers. The deck where you pull in with the cars has the planters and the stamped concrete, but they require waterproofing replacement. All repaired concrete slabs located in the parking garage are to be repaired in accordance with the ICRI, and that's the concrete repair standards. And then right here near the top of page 7 of his report, he says, however, the waterproofing below the pool deck and entrance drive, as well as the planter waterproofing, is beyond its useful life and must be completely removed and replaced. Failed waterproofing is causing major structural damage to the concrete structural slab below that area. Failure to replace the waterproofing in the near future will cause the extent of the concrete deterioration to expand exponentially. See, so he's not even saying it's going to happen a little bit. It's going to happen very rapidly from here. Well, their approach is different from what is specified in the contract documents in numerous aspects, which are described below. This is the crux of where I sort of tend to disagree with him a little bit. He's claiming here the reinforced concrete slab is not sloped to drain. The water sits on the waterproofing until it evaporates. This is a major error in the development of the original contract documents developed by this is the original architect. If you look here, there's a picture. The architect did show the sloping to the drains. So either it wasn't sloped to the drains when the contractor built the place, or somebody came along later and did something and made it flat. Or maybe the paver guys did something to it. We don't know. There's a lot of unanswered questions here. So in 1996, a contractor came in and did a $156,000 job for planter waterproofing, paver installation, concrete structural repair in the parking garage. Contractor's letter to the city said they were going to repair 500 lineal feet. A PE engineer signed off on it later that year. Okay, now this is that famous family that barely escaped with their lives. They lived right here in Unit 111, which is directly in front of column M10 was that failed, that we think. Their unit is directly over the garage, and it's directly over that point where everything fell. That's why they heard all of that noise and pounding, and they were wondering if there was construction going on. So she runs out here, goes to the lobby, talks to the security guard, complains about it, tells them to call 911 because she hears the pounding, and then sees the garage collapse right over here. They all take off running out the front door, and then you hear the famous 911 phone call. Another thing I didn't like, this is from the garage looking east towards the pool deck, is I didn't like the way all of these rebars just stripped right out of the ceiling. It looks like it came right out of wet concrete. They seem to be corroded hanging up there. See that? And why are they always stripped clean? Like there's not even a chunk of concrete hanging to them like this right here. All of them around the whole rubble pile were like this. Okay, so this will help explain why the concrete can crack from the water. So in a normal paver brick pool deck area, we should have our concrete here. The yellow represents waterproofing, and then usually about an inch of sand, and then the pavers go on top, and then the drain on top of there. The deck still should be slanted downward. Okay, so now we're showing you what happens with rain, and the water just sits there, and it pools, and it doesn't have anywhere to drain, and it tries to slowly percolate through the sand, and water weighs 8 pounds per gallon. And remember, even through all of the little, grout lines here between all of the pavers here, these little channels, you're going to have water sitting there, and even above, as we saw in the photo. So that's going to add a lot of weight. Well, we still have a lot more to talk about in this condo collapse, so we'll take up more of that in the next videos. We'll see you on the next one, folks. Thanks for joining us.